Welcome to ISU Gen Chem Lab Tutorials. In this lesson, we will learn how to use a spectrophotometer. When you are ready to use the instrument, it should already be turned on with its home menu displayed. This menu can be returned to by pressing the Home button. On the right-hand side are the up, down, left, and right-facing arrows, which are used to navigate within the various menus. And the button in the middle of these arrows is the Enter button, which allows us to select our menu option. We'll use this button to zero the instrument with a blank solution. With the Spec 200E Modern Interface option highlighted, press Enter to access the application menu. If we don't know the optimal wavelength for our experiment, we should start with the Scan application, where we have the option between absorbance and percent transmittance output, as well as defining the low and high end of our wavelength scan. By turning the knob clockwise or counterclockwise, we can increase or decrease the wavelength in 10 nanometer increments. By pushing down on the knob and turning it, we can increase or decrease the wavelength in 1 nanometer increments. When we are satisfied with the scan settings, navigate to Next and press Enter. We are now ready to clean the cuvette. Hold the cuvette by its frosted sides and fill the cuvette with a small amount of deionized water. Empty its contents into a waste container and repeat this cleaning step 2 additional times with more deionized water. Then fill the cuvette at least 2/3 full with deionized water, which will serve as our blank solution for this experiment. Finally, wipe the non-frosted sides of the cuvette with a chem wipe to remove any smudges that may be present. Open the sample compartment and place the cuvette in the cuvette holder oriented specifically such that the triangle on one of the non-frosted sides is facing right. The importance of this proper cuvette orientation can be simply demonstrated. If the cuvette is oriented such that the triangle in the cuvette is facing right in the cuvette holder, then the path the light beam travels is through the non-frosted sides and is largely unaffected. However, if the cuvette is turned 90 degrees from the correct orientation, then the path of the light beam is through the frosted sides and is noticeably and significantly affected, resulting in inaccurate measurements. After closing the sample compartment, press the Zero button. When Auto Zero disappears from the screen, you may remove the cuvette from the cuvette holder and pour its contents into the waste container. Then rinse your cuvette with 3 small volumes of your solution. Finally, fill the cuvette at least 2/3 full with your solution. Making sure to wipe the non-frosted sides with a chem wipe. Then place the cuvette in the cuvette holder, oriented such that the triangle is facing to the right. Close the sample compartment and press Enter to generate an absorbance spectrum of your solution. When the scan is complete, use the knob to move the vertical line to yield information about the absorbance values at various wavelengths. We are usually most interested in the wavelength of highest absorbance, which is known as the analytical wavelength, which is approximately 508 nanometers for this solution. Once we know the analytical wavelength for our solution, it is usually best to use the Live Display application. The Live Display application will give us the option between absorbance and percent transmittance output, as well as allowing us to change the wavelength if necessary. This application gives us a real-time reading of the absorbance of our solution at 1 wavelength. This is especially important if we expect the absorbance of our solution at that wavelength to change over time. When we are finished, return to the Home menu, remove the cuvette from the cuvette holder, Pour its contents into a waste container and clean the cuvette with at least 3 volumes of deionized water. Finally, set the clean cuvette near the instrument to air dry.